Ever wanted to build a working dashboard, generate custom music, and run deep market research in under 10 minutes without knowing how to code? Welcome the basics of AI. Think of AI as a set of nesting dolls, Bala 1. It starts with the broad field of AI and zooms into machine learning and lands onto DNN, which is a deep neural network port 2. From there, we hit the generative AI explosion. On one side, we have LLMs, which are the large language text experts like GPT-4. On the other side are the diffusion models, which are the creative engines behind AI art, like Midjourney, used for images and videos. They are different architectures that we will go into the depth of later on, but they both live under the same generative roof, transforming how we interact with technology. Now, let's explore Google Gemini. What is this screen? This is like a dashboard, so you can maneuver different models from here. I can access the LLM from here through text prompts, or you can use the images, which use image gen or transformation models behind the scenes. This dashboard is like a car dashboard where you have controls, and then from these controls, you access the engine of different functionalities, like the LLM engine behind the scenes. Now let's start with a basic LLM demo using Google Gemini. Let's give a very simple prompt. I'm a non-technical person, and I want your advice as a financial advisor. I am looking for a stock Google. Give me a technical analysis of Google for the next 1 year. Very simple prompt. I pick the model, which is a default model, and I press the button to start. Gemini gives me output on this window. It's looking ahead at the core trend, the key price zones to watch, the 1-year forecast, scenario advisor insider. Next step, it also gives me the references where it got this output from. This is a very basic use case of Google Gemini LLMs. The very fundamental idea behind the LLM is the next word prediction you might have seen in Gmail and so on. Next, let's explore how this LLM works behind the scenes. The first step is Tokenizer, the second step is embedding, the third step is self-attention, the fourth step is prediction. Let's go through the first step, how the Tokenizer works. Let's go to this website platform, OpenAI and Tokenizer. It has different options for GPTs because this is from the OpenAI. We will go through in detail later on what GPTs are and what are these different models. But let's first understand how Tokenizer works. Let's use our old prompt that we used in Google Gemini. What it does is basically it shows the tokens used for this problem. Tokenizer splits this prompt into different tokens. A token is each part of the text. In our case, the prompt is split into 49 tokens. It has a total of 197 characters, and you can see all the tokens are split into different parts of the sentences. Person is one token, comma is another token, and once all the tokens are created from a given prompt, those tokens are going to be used for the LLM intelligence. When we say the tokens used, or how many tokens are used by LLM, or the price per token, this is what the token means in the LLM world. Now let's go through the second step, how the embeddings work. For the embeddings demos, let's go to the TensorFlow website. Let's say we look for the word king. This tool is visualizing the three-dimensional data to understand how the word king is used. AI computers do not understand words as letters. They understand them as a list of numbers. We also call them vectors. As we can see, the word king is represented by a list of more than 7,000 numbers or so. AI looks up the specific vector of those numbers that represent the concept, the word king, in its learned space. The tool takes around 7,000 numbers, uses math, and maps them into the three-dimensional or two-dimensional space. This way, we can actually see that it calculates the distance between the king vector and every other word vector in its library. Words surrounding the word king, like queen, throne, son, emperor, and so on, are the ones that have mathematically similar sets of numbers. What does a cosine and Euclidean distances mean? Cosine distance measures the angle between two vectors, basically the distance in the three-dimensional space between these two numbers. So it shows how close they are. If they are pointing in the same thematic direction, they are considered similar. That shows it's closer in meaning than the others. Euclidean distance is the straight line distance between 2 points in space. If the points are close, the words are considered related. What it shows is that the visualization proves that AI has learned the relationship between concepts, and that's where it gives the meaning of the words. In this case, the word king, surrounded by queen, throne, emperor, and so on, we see that AI's internal map of meaning, and this graph for this relationship gives them meaning to the word. When we ask AI, we are essentially looking at the engine room of the LLM. seeing exactly how it classifies concepts based on how they relate. Now let's talk about the third step, self-attention. We see here that the concept of king at the center of the neural web, the glowing lines connect king to related concepts like throne or queen, indicating a high attention score. The model dynamically prioritizes these connections to understand that, in this specific sequence, king refers to a monarch in a royal context, not just a random chess piece or surname. This is giving the meaning and the connections to the different words from king. Now let's talk about step 4, prediction. Here, the input king, now processed with context from the self-attention stage, is fed into the model. The infographic shows multiple paths where the model calculates the probability of what comes next. The strongest path predicts queen as a likely conceptual sequence, visualized by a pair, an image demonstrating how king directly influences related outputs. Other contextual branches, like England or rules over the land, show how different phrases are generated based on probability. So this is the concept of how LLMs work behind the scenes. Now next, let's demonstrate images. For images, let's go to the new chat. Let's select the images, create image. You can also create the image from the above templates. There are a number of templates provided by Google Gemini. You can also create the image based on the prompt. For our demo, let's start creating an image using a prompt. This is a basic prompt, detailed enough to create the more meaningful image that we are looking for. As we can see, the image is created based on our description. It has the chroma as the title of the magazine cover, Future of AI, May 2026, so this is how you can create the image we saw earlier. You can also create the images from the samples. We can also attach an image which asks Google Gemini to convert to origami. We can choose photo here, or we can give a prompt. It says origami portrait made of physically folded origami paper with sharp, clean lines and patterns on the paper, inspired, and so on. This is a prompt pre-installed by Google Gemini. This picture is created as an origami for your cases, so this is how the images are being used now. Next, let's discuss the canvas feature in Google Gemini. Let's go to the new chat. Let's select canvas from here. Let's give a prompt. We are just saying that, act as a lead full stack engineer. Create a high-fidelity interactive dashboard for a personal investment portfolio. These are the requirements, DOS visuals. Use Tailwind CSS for a modern dark mode components, include a sidebar for navigation, a line chart using Chart.js, etc., logic code, and React. Add a transaction button, and so on. Integrate a placeholder section for Gemini Insights, where the AI would provide tactical trading advice based on the data. This is a prompt with the details of what all we need in the canvas we selected. The canvas here, let's keep the Flash model and try to generate the canvas. It opens the window on the right side and says, I'm about to generate a single file, highly interactive React dashboard, and so on. It's generating the dashboard in the right side window. Here you see two buttons. One is the preview and another is code. It creates the HTML code, which you can also copy-paste into your application or wherever you would like. Here it says, I have developed a highly interactive, functional, and premium-grade personal investment portfolio dashboard. Key aspects: dynamic visual architecture, flexible calculation engine, transaction sandbox, and so on. It just gave a name by itself. I didn't even ask for it. It's kind of the dashboard it creates. Here's the code. We asked to give code in React, therefore it gave code in the React format. You can copy-paste the code. You can also share it. You can copy contents and share. Next, let's try a different prompt for a research report. Let's give a prompt that we are asking it to run a deep research report on the current state of agentic AI workflow market for small to medium businesses in 2026. Research requirements: competitive landscape, technical architecture, user adoption barriers, ROI case study, this is the output. Strategic market briefing, executive summary, comparison, etc. It's creating the report. A strategic marketing briefing, executive summary, competitive landscape, technical architecture of 2026 agentic flows, multi-agent orchestration, advanced RAG, a long context window, and so on, and the tactical recommendations for a new startup ROI comparisons. Now, from this research report, you can also create a web page, infographics, quiz, flashcards, audio overview, and so on. Let's create infographics and see how the infographics look. It's showing those infographics with decent graphics and charts, etc. If you want, you can share details using a link. You can also go directly into this link and get it like a web page. You can also share it on LinkedIn, Facebook, Reddit, etc. This is so cool. You can also copy the code as we shown earlier. I also tried creating animations, which are also supported by Canvas. You can give it a try by giving a prompt that creates an animation, and Canvas will do that for you. Now let's go to the next section, and let's try to play around with some music. We are in the Google Gemini. Select Create Music. We can either select the music from any of these themes or create the prompt. Let's create a prompt for our demo. We are asking Gemini to create a high-fidelity 30-second cinematic synthwave track that transitions from a minimalist atmosphere. Currently, Google Gemini creates the track only for up to 30 seconds. Okay, it created the music file. Let's play it. Isn't it so cool? We can download this audio, upload it to LinkedIn, WhatsApp, and Facebook, etc. Now let's explore guided learning next. Let's select the guided learning and give a prompt. Initiate a comprehensive learn session on the technical evolution and implementation of agentic workflows and multi-agent systems. This is what we want to learn about. Break this down into an interactive, multi-layered syllabus that covers conceptual shift technical architecture, advanced RAG local versus cloud deployment for the demo include, a visual knowledge map of the agentic lifecycle, a quiz to test my understanding of chain of thoughts versus tree of thoughts, thoughts prompting, a practical coding exercise in Golang or Python to build a basic autonomous research agent, make the tone highly technical yet accessible for an advanced software architect. This is basically what we are trying to learn based on our problem. It says, welcome as a software architect to a conceptual shift from prompts to loops. It's giving the React architecture, the agentic lifestyle, and so on. Then it asks a question. So it's more of a quiz-based learning. It says an autonomous research agent needs to solve a multi-state optimization problem where early mistakes can invalidate the entire downstream execution path. Strategy A and strategy B are given. So it's asking which strategy is structurally required. Do we need a chain of thoughts or the tree of thoughts? Let me say A, and based on my answer, it asks me the next question. It's explaining what my option is: the technical architecture, the orchestrator, advanced RAG, corrective RAG implementation lab, and so on. This is the way you learn using Google Gemini. Next, let's explore deep research in Gemini. Let's do deep research here and set the thinking model to extended. If we wish, we can also add the sources and files into the deep research, but for now let's just add the prompt. We are asking a big prompt for Gemini to do deep research on a very broad and deep topic. We are saying, act as a world-class multidisciplinary intelligence and research task force with experts in so many areas like geopolitics, economics, AI, military strategy, semiconductor engineering, energy systems, and so on. Your task is not to give a shallow summary. Your task is to perform an elite-level deep research investigation into the following questions. Who will control the global economy and technological power structure by 2040? What chain reactions between AI, energy, semiconductors, demographics, geopolitics, robotics, climate pressures, and capital markets will determine the winners and losers? This must feel like a classified strategic briefing prepared for these audiences like heads of state, Fortune 100 CEOs, top hedge funds, and so on. Research requirements: perform an exhaustive web search before answering. Cross-reference independent sources before making claims. Use current data, explain incentives, and so on. Your analysts must include the AI power hierarchy, and we are giving it more details. The semiconductor war, energy as the new oil, robotics and automation, geopolitical reordering, financial and market consequences, human society impact, black swan events, contrarian insights. 2040 scenario modeling for each scenario, including timeline, geopolitical shifts, economic consequences, technological landscapes, labor market, investment, societal impacts. Estimated probability, we are asking Gemini to provide the scenarios based on our output requirements. Write like a top-tier strategic intelligence report. Use tables, comparative frameworks, probability estimates, and include confidence level, and so on. Final output should feel like a Rand Corporation Future of Civilization report, mixed with McKinsey analysis, combined with top hedge fund micro research, etc. Do not rush. Take the time necessary to conduct genuine deep research and produce the highest quality analysis possible. We are giving the whole prompt, all we want, with all the details in the report and specific information about what we exactly need, and then ask it to generate the research report. Generating research plan. Here is the plan I have put together, researching 36 websites. The research report is pretty elaborate, with the heading, abstract, introduction, and so on. Let's create the infographic. It created the infographics and also gave it a name, Stratcom 2040 Global Power Architecture. The AI power hierarchy. The semiconductor war, energy is the new oil, robotics and automation timeline, reordering market consequences, SWAN event metrics, the probability of an AGI breakthrough is very high, and it will give a systemic impact. 100% catastrophic cyber attack. The probability of a catastrophic cyber attack is also very high. Kinetic Taiwan conflict, regional grid collapse, etc. Sometimes it's scary but seems realistic. You can also share this report. It also creates the code, so you can use the code in your website or some blog post. You can also download this HTML file, copy content, share with LinkedIn, Facebook, X, Reddit, or wherever. Now you have the best report generated in just a few minutes. Isn't it amazing? Let's finish our video here.